In this video we are going to look at ions. Now ions are atoms that have a net charge due to them having gained or lost electrons. We know that atoms are neutral, in other words the amount of protons and the amount of electrons in an atom are equal. And because the magnitude of the charge of a proton and the magnitude of the charge of an electron are equal, if the amount of protons equal the amount of electrons, well then the atom is neutral. So on the periodic table, all those atoms you see there are neutral. Now when a neutral atom loses an electron, it becomes a positive ion, which we call a cation, and we'll discuss that later on. So a neutral atom, when it loses an electron, becomes a positive ion. And as you will see, that is because then the number of protons in the atom are more than the number of electrons, because one electron or two or three electrons have been lost. So the net charge, the resulting charge, is positive, and therefore that atom is no longer called an atom, but an ion. And please, not I-R-O-N like the element ion. This is ion without the R. If we have a neutral atom and it gains an electron or gains more than one electron, then it becomes a negative ion, which we call an anion. And the reason for that is that the number of electrons now is more than the number of protons, and therefore it has a net or a resultant negative charge. So we're going to look at the first 10 elements on the periodic table and the ions that are formed. So we start off with hydrogen, and we're going to go very, very quickly. So this is a simulation. It's from the University of Colorado's PhET simulation app, which you also should have on your iPad, so you can go and you can play around with this app. But I have made use of this app to illustrate how ions are formed. Now, when an electron is moved into or out of an atom, it costs energy. And so that needs to be considered. So the least cost of energy, or the most efficient way to move an electron, is the one that wins. So if you have two choices in forming an ion, either to lose an electron or gain an electron, then one needs to look at which of the two is going to cost more energy. The one that costs more energy is the one that doesn't happen. The one that costs less energy is the one that does happen. So in the example of hydrogen, in the case of hydrogen, a hydrogen atom has got one proton. You can check this on your periodic table. It has one proton and it has one electron, and it is neutral. You can see here the amount of protons and the amount of electrons cancel out. So it's a plus and a minus, gives us a net charge of 0. Now, atoms are going to form ions in attempting to fill the outer energy level. Now, in the case of hydrogen, we know that the one energy level, or energy level 1, the first energy level, can only take 2 electrons. Now, there's one of two options. Either the hydrogen can lose an electron, and then there are no electrons then, or it can gain an electron and fill that energy level. Each of those options is going to cost energy to either bring an electron in or to move that electron out. It so happens that it costs less energy for the electron to leave than to add an electron. Therefore, when hydrogen forms an ion, the electron that was in the first energy level gets removed. Energy needs to be paid, needs to be put into the atom in order to do that. And in so doing, a hydrogen ion with a +1 charge results. And we write this as H plus or H plus 1. That's the chemical symbol for a hydrogen ion. So we see here that there is a proton in the nucleus, but there's no electron in order to balance that proton's charge, and so therefore what happens is it results in a hydrogen ion, an H+1 ion. In the case of helium, that sits in group 8, helium doesn't form ions, and the reason is because the atom itself in its neutral state has already got filled outer energy level. Now, to bring in 8 electrons into the next energy level in order to fill the next energy level would simply just cost too much energy and would be unstable as well, and therefore helium just likes to be the way it is. It is comfortable just being helium, so you'll find that none of these elements in group 8 naturally form ions because of the fact that they are stable and they have energy levels, outer energy levels, valence shells that are completely full. In the case of lithium, lithium sits in group 1. Lithium has got 3 protons, it's got 3 electrons, and it's got 4 neutrons. And we see that the outermost energy level has 1 electron. Remember, that's why it's sitting in group 1, because it's got 1 valence electron. Now, let's just think about this. Every electron that you move has to pay a toll fee, an energy toll. Okay? It's like if you drive on a road and you get to a toll gate, you have to pay a certain amount in order to drive on that toll gate. Well, the same is true of electrons. When you move electrons in and out of atoms, there's an energy toll, there's an energy cost that needs to be paid. And you will learn more about that when you're in grade 10, when we look at concepts like ionization energy and electron affinity. Both of them are energies involved with the formation of ions. Ionization energy is the energy required to remove an electron to make a positive ion. Electron affinity is the energy that is required and involved when an electron comes into an atom to form a negative ion. So anyway, let's look at lithium. So it's going to cost a lot of energy if you want to move 7 electrons in here to fill the energy level 2 with 8 electrons. But it's much easier and it costs much less energy just to remove that electron. Now, if we remove that electron, then the outermost energy level now becomes energy level 2, which is full. And this is what we see here. We see that the lithium ion's outer energy level is full because the electron that was there has left. It cost energy. Remember that energy had to come from outside the atom. Now we have 2 electrons in the inner energy level, but we have 3 protons in the nucleus. So we've got each positive, each proton is balanced by an electron except for that one. And therefore, we write a lithium ion as lithium plus or lithium plus 1, much the same as what we did with hydrogen. Now, I want to show you a pattern which we are going to use later on, and that is in group 1. All these elements, when they form ions, lose 1 electron. They lose that valence electron in the outer energy level, and they form a +1 ion. In your homework, you are going to have to draw the Bohr diagrams for all the ions in the first 20 elements on the back of your element cards. And just keep note of the fact, to check yourself, that when it comes to sodium and potassium, you are going to need to form ions that have got a +1 charge. So now let's move on to the next element. And the next element is going to be beryllium. Now beryllium has got 4 protons and 4 electrons. So 2 electrons in the inner energy level, 2 in the outer. And once again, it's going to cost much less energy to remove 2 electrons than to add 6. and therefore we find that these 2 electrons are removed. And they form a beryllium plus 2 ion, which we write like this, Be plus 2, and it's plus 2 because there are 4 protons and only 2 electrons. So there are 2 protons that are not balanced by electrons, so there's a plus 2 net charge. Net we mean resulting charge or effective charge, and therefore we find that beryllium it's lost its 2 electrons in order to produce a outer energy level of 2 electrons. Energy level 1 is filled with 2 electrons. Even though the initial outer energy level or energy shell, valence shell, was energy level 2, now the outer shell is energy level 1. Forms a Be plus 2, and if we're looking at patterns, which science is a lot about looking at patterns, if we go to group 2, we know that in group 1, those atoms, when they form ions, will be plus 1. In group 2, you guessed right, they're going to be plus 2. So magnesium and calcium will also form plus 2 ions, and that's important for you to remember when you complete the homework assignment. I also want to say to you that this formation of ions is known as ionization, only occurs when energy is put into the atoms. And ladies and gentlemen, that invariably happens when bonding between elements takes place, and we'll only look at bonding really in grade 9 and in grade 10 in particular in detail. If we look at boron in its neutral state, it's got 5 electrons, 1, 2, 3, 4, 5. 3 of them are in the valence shell. 3 valence electrons means it sits in group 3. Once again, it's going to cost less energy to remove 3 electrons than to add 5 to fill the outer energy level. So it rather loses the 3 electrons to form the outer energy level as energy level 1, and that results in a boron plus 3 ion. As we see here, we've got the boron has got 1, 2, 3, 4, 5 protons. 3 electrons have been lost, and those 3 electrons don't just go nowhere. They actually go into the other atom that is involved in the bonding process. But for now, we only focus on the one atom at a time. And we see here there are 5 protons in the nucleus, but only 2 electrons now in the energy levels. And so therefore, this is now beryllium plus 3. Looking at the pattern, remember we said that in group 1, it's going to form plus 1 ions, group 2 plus 2 ions, group 3 is going to form plus 3 ions. And so aluminium will also form a plus 3 ion, and you're going to need to remember that when you complete the homework exercise. So looking again, and remember repetition helps one to really remember concepts and facts. So we're going to just repeat 5 protons in the nucleus. We are not fiddling with the protons and the neutrons at all. Formation of ions, or the process of ionization, only involves the movement of electrons in and out of atoms. So now let's move on to the next group. Let's move on to carbon in group 4. Now something interesting happens in carbon. If we look at carbon, carbon's got 4 valence electrons. That's why it sits in group 4. So to fill the outer energy level, you either would remove 4 electrons or you would add 4 electrons. Now something very, very interesting happens with carbon. And guess what it does? Nothing. Carbon does not like to form ions. So carbon doesn't bond with other substances by the formation of ions, but rather takes these electrons and shares them with other substances. Now that means that carbon forms the basis of many molecules that we require for life, and it forms the basis of a whole massive field of chemistry called organic chemistry, which you will encounter in grade 10. So carbon doesn't form ions, and so we're not going to artificially look at the ionization of carbon because it basically doesn't happen. Looking at nitrogen, nitrogen's got 1, 2, 3, 4, 5, 6, 7 protons, and an atom has 7 electrons. Now we see, and this is really very important, we have 1, 2, 3, 4, 5 electrons in the outer energy level, the valence shell. That's why it sits in group 5. Now something very interesting happens. In order to fill the outer energy level, you only need 3 electrons. Compared to the removal of electrons, it's easier to add 3 electrons than to remove the 5, and so that is what happens. So when we switch over now to group 5, we find that instead of forming positive ions through the loss of electrons, we now form negative ions through the gain of electrons. So now what happens, 3 electrons are added to the nitrogen in the second energy level to fill the outer energy level. In doing that, now look carefully, there are the 7 protons. There were 7 electrons, as we saw in the previous slide, but to fill the outer energy level, the second energy level, we gain 3 electrons. This atom gains 3 electrons, and therefore this becomes a nitrogen minus 3 ion. And when it comes to non-metal ions, we add an IDE to it. So this is what we would call not a nitrogen ion, but a nitride ion. But for grade 8, we will be fine with you calling it a nitrogen ion. But when it comes to naming compounds, for instance, potassium nitride, that nitride tells us that there is a nitrogen ion in that compound. So now let's move on. Well, maybe before we move on, let's just do a quick summary. Let's go to the periodic table. Let's look here. We say, okay, group 1 plus 1. Group 2 plus 2 ions. Group 3 plus 3. Group 4 not applicable. So Na stands for not applicable. All right, now we're in group 5. I'm going to change color. Now it becomes minus 3. Now we haven't discussed this as of yet, but there is a imaginary boundary that we can draw. It looks like a set of stairs that separates metals from non-metals. So on the left-hand side, let me change the color. On the left-hand side, we have metals. On the right-hand side, we have non-metals. And around here, we find some really interesting elements that sit on the boundary of metals and non-metals. They are known as metalloids. Excuse my spelling, it might be only one L. Or semi-metals or semiconductors. Well, it's more correct to call them semi-metals, but then we make them into semiconductors through a process called doping. Now, silicon and germanium, they sit on the boundary. Silicon sits on the non-metal side, germanium sits on the metal side, but they're both very, very similar, and they form the basis of the semiconductors we use for electronics, making cell phones, computers, anything that is electronic that's got some sort of processing power has invariably got silicon or germanium or arsenic in it. And so when it now comes to ions, a general rule is that when you're dealing with metals, metals tend to lose electrons to form positive ions. Non-metals tend to gain electrons to form negative ions. So looking at oxygen, we know that oxygen is now in group 6. It's going to have 6 valence electrons, 1, 2, 3, 4, 5, 6. Yes, it's got 8 electrons in total, 8 protons, 8 electrons in a neutral atom. But now let's look at filling the outer energy level. Now we know that oxygen bonds with a huge amount of things. We think of the metal oxides, we think of carbon dioxide, we think of nitrogen dioxide. Oxygen bonds with nitrogen when lightning occurs to form nitrates, which help to fertilize vegetation on Earth. When we burn fuels, carbon dioxide is formed as we know it as a greenhouse gas. We find oxygen with iron oxide, rust, and most of the metals that we mine on Earth, we actually mine as oxides. We pull them out as compounds, and then we separate the oxygen from the metal, and then we are left with the metal which we use for all sorts of things, aluminium pots, aluminium in aircraft, etc. So now, it's going to take far less energy to add 2 electrons than to take 6 away. So let's see what happens. So the oxygen gains 2 electrons, and in so doing there's an extra 2 electrons that are not balanced by protons. So this becomes O minus 2, which is an oxygen atom, but we call it oxygen ion, we call it the oxide ion, and we use IDE as a suffix. Okay, let's look at that word. Suffix means it's a common word or set of letters that you find at the end of a name. A prefix is at the beginning of the name. So the prefix here is ox, which means it's related to oxygen. So now, this is an oxide ion, an oxygen ion, O minus 2. So if we go to the periodic table, let's do that. Repetition leads to retention. So we've got group 1 is +1, group 2 +2. This is when they form ions. Boron is +3. Carbon we can just say is 0. And then we've got nitrogen is going to form those group 5 going to form -3, -2. And guess what you think group 7 is going to form? Well, you've guessed it right if you said -1. So let's go back and let's just see. Okay, so we've got the oxide ion, and note outer energy level full, because when that happens it becomes more stable when it chemically bonds. Looking at fluorine now, fluorine is in group 7. Fluorine has got 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. Only requires 1 electron there to fill the outer energy level. We see that the atom, obviously, this would have 9 protons in the nucleus, 9 electrons, and so it is balanced. When I say balanced, I mean electrically balanced. You can see that the amount of protons, the amount of electrons is the same. But when it wants to bond, it wants to fill its outer energy level. Now, when it forms an ion, it gains an electron. But even when it bonds, there's other mechanisms of bonding called covalent bonding. Fluorine, you will not find fluorine on its own in nature, because it's very easy for it to get an electron there. So the most common way you find fluorine in nature is when fluorine, like oxygen and nitrogen, bonds with itself. We'll leave that for grade 10, but this is what would be called a free radical, and this is extremely reactive. Wouldn't be found naturally easily in nature like this. But the closest you'd find it is fluorine, where there's 2 fluorines bonded together, or where fluorine ion is bonded with something else, a metal. So now, let's look at what happens when it forms an ion. You guessed it, it filled with one electron, and so this now is F minus 1, which we call the fluoride ion. Wait a minute, fluoride, where did we hear that? Where have we heard that before? Ah, fluoride in our toothpaste. So they use sodium fluoride in our toothpaste in order to clean our teeth, because fluorine and chlorine, fluorination and chlorination, are processes where fluorine and chlorine are used to kill bacteria in our water and on our teeth, because these chemicals are very, very reactive. So this is a fluoride ion. There again, there's the suffix and the prefix fluoro. The prefix means that it is from fluorine. The suffix is telling us that it is a negative ion. This is telling us it's a negative ion, eh? All right, so we now have group 7 elements. If we go closer, we'll see that we've got in group 7 now, we have -1 ions, group 6 -2, group 5 -3. We said carbon doesn't form ions, you can say naught, and then boron is going to be +3. When I say boron, I actually mean the whole group. I mean group 3, group 2 atoms, when they form ions, will form +2. Group 1 will form +1. And let's just, for consistency's sake, group 5 will form -3. Group 6 -2. Group 7 -1. So now, let's, we're almost done. Because remember, I said we're going to do the first 10 elements. So we've got one more element to go, and that is neon. Neon, oh, we've got a full outer energy level. So neon is part of group 8, and group 8s don't react. Group 8s don't need to form ions to have their outer energy level full, because it already is. So group 8s and group 4s tend not to form ions when it comes to chemical bonding. So there we go. We've done the first 10 elements, and from the first 10 elements we have now been able to determine a pattern. And I'm now going to repeat it for the last time in this video. Here goes. Group 1 forms +1 ions. Means all these group 1 elements will form +1. Group 2 elements form +2 ions. Group 3 form +3. Group 4, we're just going to say is naught. They don't form ions. Things do get a little bit more complicated down here, but that's way beyond the chemistry of grade 8. Then we go to group, that was group 4. So let's just put that 4. Then group 8, not group 8, group 5, my apologies, for -3 ions. Group 6, -2. Group 7, -1. And group 8, which is also sometimes referred to as group 0, well, because it doesn't form ions, we could say as 0. So now, your homework assignment is to take your 20 element cards and to draw the Bohr diagrams of all 20 elements. So that's going to be from hydrogen all the way through to calcium. So you're going to end here. This is where you're going to end. Right. Now you have already made 20 cards. You've drawn the Bohr diagrams of those 20 elements atoms on the front side. Now on the reverse side, you need to draw the Bohr diagrams of the atoms for each of the 20 elements, not as neutral atoms now, as the ions that have been formed. Now, I suggest you do this in pencil first, because it's more than likely you're going to make some mistakes, and that's cool. Remember, it's cool to make mistakes in science because it means you're trying. First, do them in pencil. Remember that for these elements here, they are each going to lose an electron in the outer energy level and form a +1 ion. These are going to lose 2 electrons in the outer energy level and going to form a +2 ion. Boron and aluminium are going to lose 3 electrons in the outer energy level and form a +3 ion. These don't form ions, so you don't need to do the ions on the back. So we can do this. We can put something special here. I'm going to put there, just say carbon and silicon. We're not going to worry about the ions, and the same for helium, neon, and argon. For nitrogen and for phosphorus, they're going to lose they're going to gain 3 electrons, become -3. Nitride, phosphide ions. Group 6 form -2. They gain 2 electrons to fill the outer energy level. So this is going to be the oxide, O-2, sulfide, S-2. You must draw the Bohr diagrams on the reverse side of your card. Fluoride and chloride, you're going to draw them as well. They will gain 1 electron to form a -1 ion, and we don't worry about this. One last thing I want to just mention. Please remember that there is this step-like boundary between the metals and the non-metals. It's a human construction, but it's a good indicator of a boundary between the metals, which sit on the left-hand side. So can you see that most of the periodic table is actually metals? And on the right-hand side of it are the non-metals. And on the boundary here, we get the semi-metals, or the metalloids. So this has been quite a whirlwind tour of the first 10 elements ions, but this is extremely important because ionic bonding is a big part of chemistry on high school level, and the formation of ions when we dissolve things is a big part of chemistry. And so the understanding of ions is exceptionally important in chemistry, and so this is why we've taken the time to invest in understanding ions on a grade 8 level.